So we're going to be looking at how to solve one-step inequalities, but before we get to that, I just kind of want to review how to graph an inequality and kind of show you. This is included in your notes, this little cheat sheet here. So again, if you've forgotten what these symbols are called, this tells you how to say them. So this is greater than, less than, greater than or equal to has the line, less than or equal to has the line, and then there's just a regular equal sign. When you're graphing it, if it's just greater than, then you're going to use this open circle. So if I'm graphing x greater than 4, then on my number line, I'm going to circle the 4, and then I'm going to draw a line indicating where the numbers are that are greater than 4, so to the right. I'm not including the 4, that's why I leave the circle open, right? So what are some solutions? Anything greater than 4 is a solution. So 5 is a solution, 4.2 is a solution, 100 is a solution. What's not a solution? 4 is not a solution. 4 is not greater than 4. 3 is not greater than 4. Negative 100 is not greater than 4. Right? And then you'll notice that these are some keywords. Is when we get to the word problems, this is very helpful. So keep this handy. Right? Then we have less than here. When you're graphing less than, again, you're using an open circle. So if I was to graph x less than 7, I would want to put an open circle around 7. Where are the numbers less than 7? They're to the left, so I'm going to shade my graph this direction. Okay, what are solutions to this? Anything less than 7. So 6 would be less than 7. 5 would be less than 7. Even 6.9 would be less than 7. Negative 20 would be less than 7. Okay, what is not a solution? Well, 7 is not less than 7. 8 is not less than 7. 2,000 is not less than 7. Okay, again, you have these words over here, smaller than, less than, and below. Greater than or equal to, okay, this when you have the line. Now you're including the number, and so you want to fill in the circle. So when x is greater than or equal to, it could be one of two things, right? So on your number line, you're going to fill in, because you want to include the negative 3, and then where are the numbers greater than negative 3? Well, they're to the right. So what are solutions to this? Negative 3 is now a solution because it could be equal to negative 3. And then what are numbers greater than negative 3? Well, anything to the right. So negative 2, positive 3, positive 100. Okay, anything bigger, negative 2.5. And what's not a solution? Negative 3.1. Anything to the left, negative 300 would not be. Okay, again, minimum, at least, no less than. All of these mean greater than or equal to. So be paying attention to those when we get to word problems. All right, less than or equal to. Again, when you draw on your graph the 0, this time you're going to fill in that circle and then shade the numbers to the left. Okay, so solutions to this equation, or I'm sorry, inequality, include 0 because of this equal to. So yes, 0 is a solution. Okay, and then anything less than 0. So negative 1, negative 1/2 is a solution. Negative 30 is a solution. What's not a solution? Anything bigger than 0. So a positive, whatever, 0.2. Okay, positive 2, positive 200. All of these are not solution. Okay, again, very handy to know these words. Maximum, at most, no more than. Because a lot of times we think maximum and we think it should be greater or bigger, but it's actually less than. And then the last one, equal to, you should be used to equal to. It's just a dot. X equals 5. If you're graphing that on a number line, it's just the number 5. The only solution to x equals 5 is 5. Anything else is going to be not a solution. So 5.1 is not a solution. 7 is not a solution. Negative 5 is not a solution. Okay? All right. Let's look at how you solve inequalities. First thing is you cut it in half. You've seen this before with equations, so it should be pretty easy. You want to isolate the variable. Same as before, it means to get the variable by itself. You're going to use inverse operations to do that. So add, subtract, add, multiply, divide, divide, multiply. Then you determine the inequality symbol. Now, the trickiest part of inequalities is this rule right here. When you multiply or divide by a negative number, you have to flip the inequality sign. All right, so this is the one time that makes it different than everything else. All right, so not when you're adding or subtracting, only when you multiply. and the number is negative. When you multiply or divide by negative, then you switch the inequality. All right, so I'll show you some examples of that in just a minute. So here's an equation. I'm going to cut it in half. Isolate the variable by doing the opposite. Opposite of subtracting, adding 3. Right? These go away. This is y. Okay, I did not multiply or divide by a negative, so I don't need to switch anything. 1 plus 3 is 4. When I graph it, I'm just going to label this as 4. It's colored in because of the equal part. And the number's less than 4 for this direction. Okay? All right, on to, I'm going to cut it in half. Isolate the m by doing the opposite, which is subtracting. Right? These go away. This is m. 6 minus 8, or 6 plus a negative 8, is negative 2. Okay, again, this was minus 8, but it was not multiplying or dividing by a negative, so I'm okay. So when I graph my answer, I'm going to circle negative 2, and I'm going to fill it in because of the equal part. Numbers greater than negative 2 are to the right. Now, one trick is this part right here points the direction of your line as long as the variable comes first. So that's kind of a trick. On this one, I'm going to cut it in half, isolate the r by doing the opposite. So I'm subtracting 7 or adding a negative 7. These go away. I bring down the r. Okay, I did not multiply or divide, so I'm okay. 4 plus negative 7 is negative 3. Now, when you get ready to graph an inequality, it is always best if the variable is first. So this is the one time I'm going to tell you to make sure your variable is on the left. If I want to change the r to this side, this is not an equation, so I can't just switch these two. I have to flip the whole thing over. So the r comes over here, the negative 3 comes over here, and I'm going to switch this because it's like flipping a pancake. Think about scooping up a pancake and flipping it over. You have to flip the whole thing over. All right, so when I graph this one, I'm going to label negative 3. I'm going to circle it, and I'm not going to color it in because it's only less than, and then the number's less than negative 3 go this direction. Okay. Now, just like with equations, you can check your work. You can pick a number. Any number that's part of your graph should make this true. So if I pick any number to the right of negative 2 for this one, I could pick, I don't know, 0, right? Because 0 is over here, negative 1, 0. So 0, if I plug that in, is 0 plus 8 is 8. Is 8 less than or greater than or equal to 6? Yes. Okay, so this is a solution to this equation. So inequalities have multiple solutions. That's why we graph them, is to show all the different solutions. Number 4, b over 3 less than 4. I'm going to cut it in half. This time, this is division, so the opposite is to multiply. I'm going to multiply both sides by 3. This goes away. This is b. Now, I did multiply this time, but did I multiply by a negative? No, I multiplied by a positive 3, so 4 times 3 is 12. So this does not change. Label your graph. It's not equal to, so less than is going to go this direction, so all those numbers that are less than 12 would be solutions. Okay, here I'm going to cut it in half. Isolate the end, do the opposite. This time I'm multiplying, so the opposite is dividing. This gives me an n right here. These go away. Okay, so this can be tricky. I did divide, but was the number I divided by negative? No, the number I had to get rid of was a positive 10. So that's the number you divide by. So that number is positive. The number I get is negative, because negative 40 divided by 10 is negative 4. But it's only what you divide by. So I'm not going to switch it because of that. However, because n is on the right side, I'm going to flip this like a pancake, switch the whole thing. So n goes over here, negative 4 goes over here, and then I flip this just to graph it, not because of what I was dividing by. So label your negative 4. It's going to be an open circle because there's no equal to, and then the numbers to the right are greater than negative 4. Right? Over here, I'm going to cut it in half. Okay, get rid of the 5 by subtracting or adding a negative 5. Over here, now this one's a little different because I have a minus b right here. Less than or equal to 10 minus 5 is 5. So what do you do when you have a negative variable? Well, you need to think of this. It's not just negative b, but negative 1b. So how do you get rid of the negative 1? You divide. This is times negative 1. So divide by negative 1, divide by negative 1. Okay, so those go away. This is b. 5 divided by negative 1 is negative 5. Okay, but you divide it, and the number you divide it by, the number that you were trying to get rid of, was negative. All right? So then that means this inequality switches to greater than. So when you graph it, make sure you graph it correctly. It's going to be a closed circle because of the equal to. Numbers greater than -5 are to the right. Right, on 7, I'm going to cut it in half. I'm going to divide to get rid of the -4. All right, these go away. This side is a. -16 divided by -4 is a +4, but you divide it. Did you divide by a negative? Yes, the number you were trying to get rid of right over here was negative. Now, you didn't end up with a negative, but that doesn't matter. It's what you divide it by, right? So since I divide it by a negative, this switches to greater than or equal to. So then when I graph it, I'm going to put 4. It's going to be a closed circle. To the right would be greater than 4. Okay, last one. I need to get rid of the divide it by 8. I do the opposite of dividing, which is multiplying by 8. I'm going to multiply both sides by 8. Okay, this number goes away. This is r. -2 times 8 is -16. The number the number I multiplied by that I was getting rid of was positive. Okay, did I get a negative? Yes, but not because of the 8, okay, which is what I had to get rid of. So this does not change, it stays less than. So when you circle it, make sure you're graphing less than. So that is to the left. All right, so a couple things to remember again with inequalities. Make sure if you multiply or divide by a negative, you flip the inequality, okay? Also, if for some reason your variable ends up on the right side, you want to flip the whole thing like a pancake before you graph it. There's nothing wrong with this, but when you graph it, you want it to be on the left side. Okay, see you soon.